Time zones are something most of us deal with on a daily basis without giving much thought to the science behind them. But if you've ever wondered why a call to a friend in another country needs careful timing, or why the clock says it's noon when the sun is at different positions in the sky around the world, you're tapping into the fascinating science of time zones. Understanding how time zones work requires us to delve into a combination of geography, history, astronomy, and even politics. Our concept of time has always been tied to the movement of the Earth, specifically its rotation around its axis and its orbit around the Sun. From ancient civilizations to the present day, the idea of dividing time based on the position of the Sun in the sky has shaped how we live our lives. Before the invention of time zones, time was largely determined by the position of the Sun relative to a specific location. This was known as local mean time. It meant that every city and town had its own unique time based on when the sun reached its highest point in the sky, local noon. In ancient times, this was perfectly fine because communities were relatively isolated from one another, and travel was slow. However, as human society became more interconnected, particularly during the 19th century with the rise of the railroad and telegraph systems, the lack of a standardized time system became problematic. If each town had its own time, it was almost impossible to create accurate train schedules or communicate effectively across long distances. Thus, the idea of standardizing time emerged, eventually leading to the development of time zones. The first major step in the creation of time zones came in 1884 at the International Meridian Conference, held in Washington, D.C. It was here that representatives from 25 nations agreed to adopt the prime meridian, which runs through Greenwich, England, as the universal reference point for time. This established Greenwich Mean Time, GMT, as the standard from which all time zones would be calculated. The prime meridian became the starting point, or 0 degrees longitude, and time zones were set at regular intervals east and west of it, generally spaced 15 degrees apart. Each 15-degree segment of longitude represents 1 hour of time difference from the prime meridian. Why 15 degrees? This is where the Earth's rotation comes into play. The Earth rotates 360 degrees in approximately 24 hours. Divide 360 degrees by 24 hours, and you get 15 degrees per hour. So, for every 15 degrees of longitude you move east or west, the local time changes by 1 hour. If you move eastward, you add an hour. If you move westward, you subtract an hour. This basic principle forms the foundation of the time zone system we use today. The division of the world into time zones was not as simple as just drawing lines on a map. Many factors, geographical, political, and cultural, had to be considered. While the original concept was to have each time zone neatly aligned with lines of longitude, real-world considerations meant that time zone boundaries often follow national or regional borders, or even geographical features like mountains or rivers. This is why time zone lines zigzag across the globe rather than following straight vertical lines. Take, for example, the time zone boundaries in Europe. While most of Western Europe, including countries like France, Spain, and Germany, is within what should be the same time zone based on their position relative to the prime meridian, political and historical decisions have led to some variations. Despite being west of Greenwich, countries like France and Spain follow Central European Time, CT, which is 1 hour ahead of GMT. This was a decision made during World War II and has persisted ever since. Similarly, the United States has 4 main time zones: Eastern, Central, Mountain, and Pacific. While these time zones largely follow lines of longitude, there are a few anomalies due to state boundaries and practical needs. For instance, parts of Indiana used to observe a different time zone from the rest of the state, and Arizona does not observe daylight saving time, creating a unique situation where the state operates on a different time schedule during parts of the year. Daylight saving time, DST, adds another layer of complexity to the concept of time zones. Introduced during World War I as a way to conserve energy by making better use of daylight, DST involves moving the clock forward by 1 hour in the spring and back by 1 hour in the fall. This practice is still used in many countries today, though not all follow it. Regions close to the equator, where the length of day and night remains fairly constant throughout the year, generally do not observe DST, while countries further from the equator often do. But let's return to the idea of how time zones are tied to the Earth's rotation. Time zones are based on the position of the sun in the sky. As the Earth rotates from west to east, the sun rises in the east and sets in the west, causing different parts of the planet to experience day and night at different times. When the sun is directly overhead at the prime meridian, it is noon in Greenwich. At that same moment, it is earlier in the day in the Americas and later in the day in Asia and Australia. This pattern repeats every 24 hours as the Earth completes one full rotation. To understand the significance of time zones more deeply, let's take a closer look at how time changes as you move around the globe. Starting at the prime meridian in Greenwich, we move eastward, adding an hour for every 15 degrees of longitude. For example, in Berlin, which is approximately 15 degrees east of Greenwich, the local time is 1 hour ahead of GMT. Continue moving east, and by the time you reach Beijing, China, you have moved across 8 time zones, so the local time is 8 hours ahead of GMT. If you keep traveling eastward, eventually, you'll cross the international date line, located at approximately 180 degrees longitude in the middle of the Pacific Ocean. The international date line is where the calendar date changes. When you cross the line from east to west, you move forward 1 day. When you cross from west to east, you move back 1 day. The international date line exists because the Earth is a sphere, and at some point, there has to be a place where the time difference results in a change of date. If the entire planet operated on the same date and time, it would create massive confusion, particularly for international travel and communication. For instance, if you were flying from New York to Tokyo, you would cross multiple time zones along the way. By the time you arrive in Japan, the local time would be several hours ahead of your departure time, even though only 13 or so hours may have passed in real time. The same principle applies in reverse when traveling westward. Time zones are essential for managing these differences and ensuring that people around the world can coordinate activities like flights, business meetings, and phone calls. The international date line does not follow a perfectly straight path. It deviates in several places to accommodate the political boundaries of countries and territories. For example, the line bends eastward to ensure that all of the Aleutian Islands in Alaska remain on the same calendar day as the rest of the United States. Similarly, some Pacific Island nations, like Kiribati, have shifted the date line to ensure that their entire territory shares the same time and date. Time zones also play a crucial role in global communication. With the advent of the Internet and the rise of the global economy, businesses and individuals are increasingly operating across multiple time zones. Coordinating activities between time zones requires an understanding of how local time differs from other regions. In today's interconnected world, where meetings, transactions, and even social media interactions occur across continents, time zones help to keep everything organized. In modern times, Coordinated Universal Time, UTC, has become the standard used by many industries and organizations, especially in fields like aviation, computing, and telecommunications. UTC is closely related to GMT but is more precise due to its reliance on atomic clocks, which are the most accurate timekeeping devices available. While GMT is still commonly used, UTC has become the official standard for timekeeping, particularly for activities that require synchronization across time zones. Beyond the practical aspects of time zones, the science of time itself is deeply tied to our understanding of the universe. Time is a fundamental concept in physics, with theories like Einstein's theory of relativity showing that time is not absolute but can change depending on factors like speed and gravity. While time zones are based on the Earth's rotation and its position relative to the Sun, the nature of time itself is a much more complex and profound topic. In essence, time zones are a human invention designed to bring order to a world governed by the movements of the Earth and the Sun. They reflect both the natural rhythms of the planet and the practical needs of human society. Time zones help us navigate the complexities of our global world, ensuring that people in different parts of the Earth can coordinate their activities despite the vast distances that separate them. From their origins in the 19th century to their essential role in modern life, time zones remain one of the most important and fascinating aspects of how we understand and manage time. As we continue to explore space and look beyond our planet, the concept of time zones may evolve further. Already, space agencies like NASA and private companies planning missions to the Moon and Mars are grappling with how to measure time in a way that makes sense for space travelers. While the principles of time zones are firmly rooted in the Earth's rotation and its relation to the Sun, future exploration may require us to rethink how we measure and experience time. For now, though, time zones remain a vital part of life on Earth. Whether we're scheduling a meeting with colleagues in another country, watching the sunrise at different times depending on where we live, or counting down the seconds to the new year as it sweeps across the globe, time zones connect us in ways both big and small. They remind us that, despite our differences, we all live on the same planet, rotating through the same 24-hour cycle, one time zone at a time.